Okay, so we're just going to start with some examples or go over some examples here where we just focus on determining claims and the null and alternative hypotheses for performing one sample hypothesis tests. So this is all about chapter 7. Okay, now, so basically, we're just going to run through a few examples. So, this first example, take a moment to read it. Okay, so the first thing you want to do is you want to figure out, let's see here. So, step one is you want to figure out the population parameter that is being studied or tested. Now, there are four main population parameters that are addressed in this book. So, you've got the population mean, you've got the population proportion, P, you've got population standard deviation, S, or sorry, that should be sigma, and you've got the population variance, sigma squared. Uh, so let's see here. 7.1 and 7.2 deal with mu. 7.3 deals with P. Oh, sorry, let me change this. 7.2 and 7.3 deal with mu. 7.4 deals with P, and 7.5 deals with sigma and sigma squared. Okay, so that's going to be step one, is to determine your population parameter. And then step two is going to be to write your claim verbally. Step three is going to be to translate the claim or write the claim as a mathematical statement. Step four is going to be to negate that statement. And what's the it? It is the claim that you wrote in step three. Okay. And then step five is going to be determine H naught and HA. And then you're done. All right. So with this written down, let's see here. Going here, I'm going to highlight what we have. So, so notice it says, can you support the publications claim? So that means our hypothesis test is about the publications claim. So we go back and say, what is the publications claim? Oh, the publication claims that the mean score for grade 12 students on a science achievement test is more than 145. So I am ready to, let's see here, copy. I'm just going to go ahead and fill in each of these. Now, what is the population parameter? The population parameter is mu because we're working with mean score. So the population parameter is going to be mu. And what does mu represent? Mu is going to represent the mean score for grade 12 students on the science achievement test. Now we could add in all the details, but uh, just if we have time, we can. Step 2, write the claim in English. What is the claim? The claim is that the mean score is more than 125. Right? So we've got mean score is more than 125. So I'm just going to write that here where it says to write the claim in English. Was it 125 or 145? 145. Now I write the claim as a mathematical statement. Here we go. Mu is more than 145. Now I negate it. The negation of mu is greater than 145 will be mu is less than or equal to 145. Okay. And now, if you notice, we now have two mathematical statements. This is the first one, and this is the second one. So we have to determine which is our null and which is our alternative hypothesis. For us, the null hypothesis is going to be the statement that contains the equality. So because this statement has that equal sign, less than or equal to, this is going to be our H naught. Our alternative hypothesis always contains the inequality. So to say that mu is greater than 145 is a statement about inequality. Okay? So we're done. So H naught, in conclusion, is going to be mu is less than or equal to 145. And HA is going to be mu is greater than 145. Which one is our claim? Our claim is H sub A. Okay. So by the way, I kind of want to point out that we uh, usually we enter statistics into our calculator when we're performing hypothesis tests. However, here we are given data. So if we were going to use our calculator, we would um, let's see. So I'm just skimming this, and I'm noticing that we are not given a population standard deviation. So we're not given a population standard deviation, but we are told that n is 36, which is greater than or equal to 30. So we can use the central limit theorem to conclude that the sampling distribution is going to be normally distributed. So we can go ahead and actually do a t-test. And with this t-test, we would enter the data into L1. And then when we do a t-test, instead of going over to stats, we would just use hit data and tell the calculator to use the data from L1 with a frequency of 1 and perform the hypothesis test that way. Okay. All right, let's look at this one. Okay. So take a moment. So our claim is about the mean annual production of cotton. Okay. So we are ready to write down the population parameter. Population parameter is going to be mu. What does mu represent? Mu represents the mean annual production of cotton per country. So the units are bales per country. Now, this is population mean, so we don't know mu, right? We don't know the population mean. The idea is to test a claim about the population mean. Write the claim in English. Mean production is 3.5 million bales. All right, write claim as a mathematical statement. That's just going to be mu equals 3.5 million. Now, to negate it, the negation is going to be mu is not equal to 3.5 million. And you could write 3.5 and assume that your units are actually millions of bales per country. And I think that there was actually one little homework assignment that we had that talked about homework question that talked about linear transformations of random variables. So it's okay to essentially multiply all of our values by million, right? And we can just have the millions accounted for in the units, and that won't change any of our results. Now, we have our mathematical statement and we have the negation, so we're ready to determine H naught and HA. Remember, H naught is going to be the statement that includes the equality, and HA is going to be the statement that includes the inequality. So we are done. Now, which one is the claim? The claim in this case, the claim is H naught. So a lot of students will think, oh, the claim has to be H naught. No, 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 the claim doesn't have to be H naught. In fact, we just looked at an example back here where the claim was, right back here, the claim was actually HA. So each time you have to determine is your claim H naught or is your claim HA. Okay, let's look at this next example. And what do we think our population parameter is? A key phrase here or a keyword, percentage. So anytime you're talking about a percentage of the population doing this, you're discussing proportion. So note that we have a polling agency reports that over 40% of U.S. adults say they are less likely to travel to Europe in the next 6 months for fear of terrorist attacks. All right, so that's a really long statement of the claim, but our population parameter is going to be P. And what is P? P is going to be equal to the proportion of U.S. adults scared to travel. Okay? What is the claim? The claim is that P is greater than 0.4. Right? So that's this over 40% is saying that P is greater than 40%. Or we can write that as just P is greater than, oh, sorry, I'm actually kind of doing this next step here. P greater than 0.40. So in English, the claim is more than 40% of U.S. adults are scared to travel. Okie dokie. What's the negation? P is less than or equal to 0.40. And finally, which one is H naught and which one is HA? H naught is going to be the statement with the equality, less than or equal to, and HA is going to be the statement with the inequality, strictly greater than. In this case, our claim, right, our claim is more than 40%. So our claim is HA. Okay. And one last one here. So is there enough evidence to support the travel analyst's claim? What does the analyst claim? The analyst is claiming that the mean price is less than $507. This must be a statement about mu. And what is mu? Mu in this scenario is mean price of round trip flight. Now, write the claim in English. Mean price is less than $507. Write the claim as a mathematical statement. Mu less than 507. Negate it. Mu greater than or equal to 507. My null hypothesis is going to be the second statement. My alternative hypothesis will be the first statement. So my claim is the alternative hypothesis this time. All right. So do you remember that the only way that you can conclude that there's enough evidence to support the claim is if the claim is the alternative hypothesis? This is just the ramification of how we interpret the results of the hypothesis test. Yeah, and I think that's, oh, did we not already do that? Did we already do that? Yeah, we just did that one. So we're done. That's it. All right, I hope this is helpful.